Hello everyone and welcome to Exam Ignite. Today I am starting with the module 3 part 1 of microcontroller, that is BEC405A for VTU 4th semester 2022 scheme. In this video I'll be discussing an important and frequently asked concept, that is timer and counter in 8051, TCON and TMOD registers, and programming examples, that is mode 1 and mode 2. So this is one of the most repeated topics in the VTU exam, and understanding it will definitely help you to score better. So let's begin with the video and stay till the end for the clear handwritten notes and the important points that are marked for the revision. So let's get started. Uh, TCON and TMOD, as I said, it has appeared in many of the papers, and then data types and time delay in 8051C, that is the second concept. Programming 8051 timers, that is my mode 1 and mode 2. These are the main four important topics that I'll be discussing in today's video in the part 1. Next, part 2, I'll continue with the serial communication input or output, that is ESCON, and then RS-232 connection, then program to transfer data serially and to receive the data serially, and also full duplex, half duplex, and simplex, and also the two majorly asked problem. Also you have to learn the ALP programs and the C programs. One is to get the S, and another one is to get A serially, and the ALP program for multi-byte data serially using a 9600 baud rate. So that was in the model question paper 2. So this is how the important concepts are. So let's get started. Yeah. So in this, counting and external events such as the frequency of a pulse train or the generation of the precise internal time delays, software loops for the counting and timing keeps the processor occupied. So to relieve the processor, two 16-bit up counters named T0 and T1 are provided for the programmer. Each counter may be programmed to count the internal clock pulse, acting as a timer, or the program to count the external pulses. So basically, 8051 has two timers or counters. So what does actually the timer do? It is generates the time delay, and also it maintains the timing of the operation in sync with the clock. So we are having two. One is 16-bit T0 and 16-bit T1. So here it is again having THO and TLO. Again, it is having TH1 and TL1. Basically, TL is low byte register and TH is high byte register. So counters, these help in counting the number of events that has happened outside the controller. Next comes, there are two controller registers, that is TMOD, timer mode control register, and uh, timer control register, that is TCON and TMOD. So these are the two registers in the timer or counter. These are of 8-bit registers. Okay. Next, this is our timer or counter logic. How does this work? So basically, frequency oscillation is given. It is divided by 12D. Why? To get the output frequency. It is divided by 12D. And if that is connected to the C by T bar is 0, if it is connected to that, then the TMOD will be acts as a timer operation. If it is connected to 1, it acts as a counter operation. So finally, T0 timer stages depends. So here another factor is we have to place an AND gate where the input will be one TR, that is input or output bit in the TCON, and the another one is the gate bit in the TMOD, that is inverted, and another one is the external one, that is int 1 or 0 input pin for giving to the OR gate. That output is taken as input for the AND gate. This is our timer or control logic. So as I said, counter is, it counts the increments from the initial number to the maximum and then rolls out to 0 on the final. So sets a timer flag. The flag condition may be tested in a program. Timer, that is a counter, is configured as a timer. It is the count the internal clock frequency divided by 12. For example, if you are having 6 megahertz, then the timer clock will have 500 kilohertz. So the C by T bar bit of the TMOD is 0, then the bit Rx is TCON is 1, and the gate bit is TMOD is 0, then the external pin int X is 1. So coming to the next topic, we will get started with the TCON, structure of TCON. So here it is as it is an 8-bit register. Let us see here. It is having IT0, IE0, IT1, IE1, then TR0, TF0, TR1 and TF1. So this TCON, it helps in starting and stop of the timer, and it to provide the status of the external input, like whether we are using the int 0 or int 1, we use this TCON register to get to know. And it also helps us to provide the status of the timer flag overflow, that is TF0 is on or TF1 is on. And it also helps to configure the interrupt, that is whether it is a level triggered or edge triggered. So this timer control register, it controls the operation. So let's go in depth. So first one, let's start with the TF1. This TF1, it is a timer 1 overflow flag. This is set when timer or counter is overflows. This is our first point. Similarly, TF0, this is what timer 0 overflow. This is set when timer or counter is 0 overflows. Next is TR1. TR1 is timer 1 run control bit. This is 1. This will be 1 when enable timer to count. So it will be 0 when it is cleared by the program to half. Next comes TR0. This is a timer 0 run control bit. It is set to 1 when it enables the timer to count, and it is set to 0 when it is cleared by the program to half. So this was about the first part. Next is IE1. IE1, it is an interrupt enabled. Interrupt enabled when pin 3.3 goes low, it is set 1. If it is IE0, then interrupt 0 pin is enabled. When it is enabled, when it is here, it is pin 3.3, here it is pin 3.2 goes slow. These two get enabled. Next, int 1. This is set to 1 when it will be 1 when to trigger the input by falling edge. It will be 0 when it is triggered interrupt by low level signal. Next, int 0. This is what here it is timer 0 interrupt. This is 0 for the low level triggered, then it is 1 for the falling edge triggered. So this was about the pin bit of the TCON. So another one thing you have to notice, this TR1, TR0, I mean to say the starting 4, this start and stop of the timer depends on this. And from this part, it actually says as the external hardware interrupt, whether it is int 0 or int 1. That is what written here. TR1 and TR flags, they turn the timer on or off. Then set B TCON.6 and clear TCON 6 can be used to store the 1 and 0 in the TR1 flags of TCON register. Next, we'll start with the TMOD, that is timer mode control register. So here, this is having, why do we use this TMOD? This is to select the timer as, this to select the T0, that is timer 0 has timer or counter, this one, or else to select the timer 1 has timer or counter. So also it helps us to select the mode of the timer. So we are having 4 modes, mode 0, mode 1, mode 2 and mode 3. So lower 4 bits are used for the timer 0 and the upper 4 bits are used for the timer 1. It is the same. First is M0, M1, a counter or timer and the gate. This repeats the same. So start with the gate. If the gate is 0, what does that mean is T0 or T1 are in the run mode. Timer 0 or timer 1 will be in the run mode if this gate is 0. And TRX will be high and INTX will be high. This says that. Also, if the gate is 1, then T0 or T1 will be in the run mode when TRX is high. Only TRX is high. Next, let's go to the control or timer. This is used to select the timer or the counter. If it is 0, then it is in the timer mode, and if it is in 1, then it is in the counter mode. Next is M1 and M0. Based on the combination, it depends on what it is. So firstly, if both are 0, then it is mode 0. It is a 13-bit mode, or you can say it is an 8-bit timer or counter with a 5-bit prescaler. So 8 plus 5 is 30. Next is 0 and 1. That says it is a mode 1 and it is 16-bit mode timer or counter. So here THX and the TLX are cascaded here. Next here if 1 and 0, then it will say mode 2. That is what? It is an 8-bit mode with auto reload. Don't forget this. It's an auto reload timer or counter. If both are 1, then it is a mode 3, which is an 8-bit split timer. This function depends on the timer 0 and timer 1. So next, let's move on to the mode 1 programming. Mode 1 programming. Here, mode 1 programming, it is a 16-bit timer. So basically here XTAL that is given and that is divided by 12. So based on that, C by T bar is 0 for the mode 1 programming. That is given as a 1 input for our AND gate, and another input will be my TR. So it goes to the control where my THX and TLX are present. So here TF goes high when only FFF tends to 0. So that's it creates an overflow flag, that is TF. It sets it. So let me explain you. It's a 16-bit timer. It values from the 00 to FFFF to be loaded into the timer. So start the timer. First basically set the TR for the timer 0 and set B for TR1 for timer 1. After starting the counter, it will reach the FFFH and rolls to what? It rolls down to 0. Then it sets the TF, that is overflow, timer overflow to 1. With this, the timer can be stopped. So this stops the timer with the instruction what? Clear TRO or clear TR1. The timer 0 and timer 1. So to repeat the process, TH and TL must be reloaded with the original value and TF must be reset to 0. So what are the steps to program? Here is first you have to load the TMOD value to the register indicating which timer to be used. This is the first point. Which timer mode, either it is 0 or 1, is selected. Now load the TH and TL with the initial count values. Now you start the timer. Keep monitoring the TF until it reaches. So jump, then TX is target. When TF is 1, get out of the loop. So then it will stop the timer. Clear the TF flag for what? The next round. Then go back to the step 2 again to the step 2. Load the TL and TH again. So here you are having a program, write a program to generate a 2 kilohertz square wave of a port 1.0 in pin 1, oscillating frequency 12 megahertz. So here it is given as a square wave. So step 1, what you have to notice, C by T bar is 0 with this timer. Now clock source to timer, that is 12 megahertz is given, divided by 12. It becomes 1 megahertz. Now the period of square wave, that is T, is what? 1 by F. 1 by 2 megahertz, which is, 2 kilohertz, that is 500 µs. So the duration of the higher and the lower pulse is what? 250 µs. Now you have to divide it. 250 µs divided by 1 µs. We get 250. So the count is 250 counts. So and the standard is 65536 minus this 250. We get this answer. On converting it to hexadecimal, we get FF06H, and that is my counter initial value. So writing a program to that, firstly, set up the timer in the mode 1. This is my first step. Second thing, clear the overflow flag, start a loop. Then place the 65286 in the timer register, that is FF06H. Then move the TL1, that is 06H to TL1. Then set B, that is enable the timer 1 to operate. Next loop is wait. When jump, when it is TF1 is there, then you have to wait. Then clear the TR1, that is stop the timer. Complement the pin port 1 0 to get the high or low. SJMP, that is short jump to back to loop. So next is another one problem with the similar values. Go through this. Next is the same thing. Again, the values are changed. That is a timer 0 mode 1 operation. Go through that. We'll start with the mode 0 programming. Mode 0, it is a 13-bit timer that can hold the values between 00H to 1FFH. When the timer reaches 1FFH, it rolls over the 00H and TF is raised. So it is a 8-bit timer and a 3-bit prescaler. So 8-bit timer and 3-bit prescaler. So here the diagram is XTL oscillator. It is divided by 12 directly given to the AND gate, and another one is TR. We give that to the timer TH and TL. So TF goes high when 1FF will be 1FFF10 rolls down to 0, and hence the overflow flag. This was about the timer mode 0 programming. And the mode 2 programming, here XTEL oscillator divided by 12 given to the AND gate, and then we give the TR that is given to the TL and the TH. Here both are mentioned separately. And overflow flag, so TF goes high when FF tends to 0. Let us see the operation, how this works. So it's an 8-bit timer. It allows 00 to FFH to be loaded in the TH. So TH value is what? It is copied to TL. Then the timer must be started. So it is done by what? Set B TR0 to TR0 for timer 0 and set B TR1 to timer 1. So TL will what? It will count up until it reaches the FFH. When it rolls from the FFH to 0, it sets the TF flag high. So when TF flag will become 1, TL is reloaded automatically with the original value by TH register. To repeat this, clear the TF, and this makes the mode 2 to auto reload. In the mode 1 programming has to reload the TH and T1. TL. So what are the steps to program here is, first step is to load the TMOD indicating the type whether it is 0 or 1 and select the timer mode 2. Then next is load TH register with the initial count values. Start the timer. Keep monitoring till the TF with the jump TFX target. When TFX is 1, it goes out of the loop. Now you have to clear the TF flag and it has to go back to this step 4. Since it is mode 2, it is auto reloaded. So based on that, here is a problem. Go through that. Next, we'll go to the mode 3 programming. Mode 3 programming is a bit different compared to those two. Here, to make the TLO to work, to make this mode 3 program to work, first we'll consider the timer 0. So this timer 0, TLO, that is 8-bit timer or counter. Okay, it is controlled by the TFO and the int opens. Both of them control this timer 0's TLO. Then THO, it is controlled by the 8-bit timer only, not the counter. And it is controlled by TR1 and it is controlled by TF1 also when it overflows. This was about the timer 0. Next, if timer 1 works, then what happens? It holds the count for events. It holds the count for events and it does not run in the timer 1. So this what we can conclude from this. There is no interrupt that will be generated in the timer 1 in this mode 3. So next, coming to the counters, when used as a counter, pin T0, that is pin 3.4, supplies a pulse to counter, and pin T1, that is pin 3.5, port 3.5 to counter 1. So C by T bar bit in the T mode will set to 1 to enable the pulses from the TX pin to reach the control circuit. So here I have written the counters mode 1 and mode 0 for the counters and timers, so you can compare it, and for the external input. So next serial port programming will be done in the next part 2 video of module 3. So I hope this was clear for you, and the all the important questions are discussed in the video completely, so make use of it. These are the direct exam questions. I have explained them in the simplest way. So thank you for watching. If you find this video useful, please don't forget to like the video, share it with your friends, subscribe to Exam Ignite to get the next updates. Thank you for watching.